Okay, so today you're going to learn how to find arcs and angles that are formed by intersecting chords, secants, and tangents. Okay, so first we're going to title this lesson 10.7. Now, reading here, when chords, secants, and tangents intersect in a circle, on a circle, or outside of a circle, special relationships exist between the angle and arc measures formed. So let's look at those relationships now. Here you can see two chords are intersecting somewhere inside of the circle. Okay, those intersections, that intersection is not the center. Here you have a tangent line and a secant line intersecting on the circle. And then here you have two secants that are going to intersect outside of the circle, of course. So we're going to be looking at these three different intersections and identify how to find the corresponding angle measures or arc measures. Let's begin. First, we have figure 1 where the intersection happens inside of the circle. So in this case, we have two chords. Here's the relationship. In order to find the measurement of angle 1, this is angle 1 here, which would be this angle. You need to take a half of the measurement of arc AD plus the measurement of arc BC. So let's look at that on the image. In order to find this angle measurement, I need to add this arc and then take a half of that total. Moving on. The measurement of angle 2 would equal a half of the measurement of arc AB plus the measurement of arc CD. So let's look at that on the image. In order to find this angle here, angle 2, I would have to take arc AB plus arc CD and take a half of that total. Let's get into some examples. I'm going to be doing the even problems. I'm going to set up the problems. However, I will not be doing any algebra. You can do the algebra on your own. Just pause the video and finish the problem. I will, however, provide the answers. Okay. Let's start with number 2. Looks like they were asking for the measurement of angle STR. So let's first go ahead and highlight the angle that it is they're asking for. So that's this angle here. Well, in order to find the measurement of angle STR, that's going to be equal to a half of the measurement of arc PQ plus the measurement of arc SR, according to the notes that we just took. So that is this arc plus this arc, and you would have to take a half of that. So that's going to equal 1/2 of 186 plus 112. Giving you your final answer of 149 degrees. Moving to number 4. In number 4, they're asking for the arc LK. So I'm going to highlight that arc. It's a little bit too big. Here we go. They want this arc here, LK, and I know the relationship of arc LK is going to be directly related to this this angle and this arc. This angle and this arc. Because if you think of the notes earlier, you know that you're able to find this angle by adding this arc and then taking a half of that. So I'm going to set up an equation. First of all, the 62 degrees is pertaining to this angle here. So, let me see what I should name this angle. L and K. Yeah. Let's say the measurement of angle L and K, it's really important to understand this part, right? The measurement of angle L and K is equal to 1/2 of the arc, of the measurement of arc JM plus the measurement of arc LK. And then just filling in that information would help you solve for arc LK, because this right here is what we're trying to solve for. That is that arc that's highlighted in the image. Okay, so I'm just going to fill that in. So we're going to get 62 is the measurement of angle LNK, and it's equal to 1/2 of the measurement of arc JM would be 74 plus the measurement of arc LK, which I don't know yet, so I'm going to call it X. All right, and in that case, you are going to have to do a little bit of solving here to find out what X is. And X is going to be equal to 50. So do these steps on your own. You should start, you should start by distributing the 1/2 into the parentheses. Okay. Let's move on to number 6. With number 6, they're asking for arc QT. And first we need to understand that in order to find arc QT, we would need this angle QUT, because according to what we just took notes on, this angle measure QUT is going to equal 1/2 of the measurement of arc QT, which is what we're looking for, plus, and see if you can figure out which arc I'm going to write here. It is RS. Okay, so we want to start out, if you're noticing a trend here, we want to start out every problem like this, because this is what we are learning in this topic. It's these two equations here that we need to learn how to use. You need to understand the relationship there. Okay? So with this equation that I've set up, I have two unknowns. I don't know the measurement of QT because I need to find it. And I don't know the measurement of angle QUT, right? So I need the measurement of angle QUT in order to find the measurement of arc QT. So first I'm going to go ahead and get this angle measure. just going by vertical angles, I know that this angle would also be 79 degrees. Okay? And then with that being said, I now know that if I do 360 minus 79 minus another 79, right? That's going to give me 202. Let me move that up. Okay? So with 202 degrees being left over in the circle, I know that this angle is 101 degrees as well as this angle is the other 101 degrees, totaling to 360. So now I can go back to my equation that I created and replace the measurement of angle QUT with 101, and that's going to equal a half of the measurement of QT. I don't know the measurement of QT, so I'm going to call it X, plus the measurement of arc RS, which is 95 degrees that's given to us in the picture. Distributing and then solving for X, I will get that X is 107. So that arc is 107 degrees. Okay? And I just want to point out a common misconception here. Notice that arc QT is 107 degrees. I should write degrees. There we go. But across from it, you have an arc that's 95 degrees. Okay? So please don't get vertical angles confused and think that you could use something similar to vertical angles to say that, oh, since this arc across from it is 95, then this arc must have been 95, right? No, wrong. Okay? That is used for vertical angles, not for arcs. However, I'm sorry, you can use it for arcs, but your chords would have to go through the center, right? It would have to be, both of your chords would have to be diameters. If they're actually diameters and they're going through the center, then sure, you could say that the arcs across from each other are congruent to each other. But that's not the case when these chords are intersecting at some random point in the circle and it's not even in the center. Okay? So just to be clear. All right, let's move on to scenario 2. So now we're going to do some problems where the intersection is on the circle instead of inside. Okay, so look at this image here. You can see that the intersection here is on the circle between this tangent and this, sorry, not chord. The tangent and the secant line, they intersect on the circle. So these equations are going to be just a little bit different. So let's fill in the equations first. In order to find the measurement of angle 1, you're going to have to take a half of the measurement of arc AB. And in order to find the measurement of angle 2, you'll have to take a half of the measurement of arc BCA. Now let's go to the picture to see that. So in order to find this angle here, right, you're going to have to take half of this arc. Okay? So this angle would correspond to this arc, half of the arc. And then to find the measurement of angle 2, you would have to take half of this arc. Okay? So that's for this angle. And notice how that angle is going all the way down to the line. So when I zoom in, it is this angle all the way down to the line, right? We're not stopping on the circle for any reason. The angle is created by two intersecting lines. Okay? And then, of course, these two angles would be supplementary or a linear pair. All right, let's go ahead and try number 8 to see if you understand these equations that we just wrote. So first question here asks us to find the measurement of angle DBC. So I'm just going to highlight that angle. That is this angle here, DBC. Okay. So seeing if you understand earlier, the measurement of angle DBC would be half of which arc? Think about what we wrote earlier and try to figure out which arc we would be taking a half of. Okay, so hopefully you wrote arc DB. Okay, so if we find arc DB and we take a half of that, we are going to be able to identify the measurement of that angle. Okay, so just looking at the given information here, that this arc is 192, I can subtract that from 360 to say that this arc is 168 degrees. Okay, so now I'm going to say that that angle measure is equal to half of 168. So we have an 84-degree angle. That's done. Let's move to number 10. Number 10 is looking for the measurement of arc K and M. So first I'm going to highlight that arc, K to N to M. All right, so if you recall from what you copied down earlier, this arc is going to be corresponding to this angle. And that angle would be MKL. So first I'm going to say that the measurement of angle MKL would equal half of arc K and M. Okay, so let's see if I can find the measurement of MKL. Well, just looking at the given information here, that this angle is 23 degrees, and knowing that these two angles are a linear pair, I can do 180 minus 23 to get that this angle here is 157 degrees. So now I can fill that in to the equation that I just wrote. So I'll be writing that 157 degrees is the measurement of MKL, and that's going to equal half of arc K and M. Right now I'm going to call arc K and M X, so half of X. Okay, dividing both sides by a half, we're going to get that X is equal to 314 degrees. And that problem is solved. Which makes sense because that's a very large arc that we have highlighted there. So for that to be 314 degrees, that looks very accurate. All right, let's go ahead and move on to our last scenario where the intersection is happening outside of the circle. All right, so you have 3 different types of intersections that could happen outside of the circle, and all of them are going to use different equations. So the first type of intersection that happens outside of the circle is when 2 secant lines are intersecting. They would intersect outside the circle. So in order to find the measurement of angle A, you would take a half of the measurement of arc CE, minus, not plus, minus the measurement of arc BD. So let's look at that here. In order to get this angle here, you would have to take that larger arc that is between the two secant lines and subtract the smaller arc from it. And then once you do that, make sure you take half of that answer. Let's look at our next intersection outside of the circle. This is when a secant line and a tangent line are intersecting outside the circle. This is what's going to happen here. You're going to have to take a half to find angle A, the angle of the intersection. You will have to take a half of the measurement of BD, arc BD, minus the measurement of arc BC. So let's look at that in the picture. To find this angle at the intersection, you're going to have to take this arc and subtract the smaller arc from it. Then make sure you take half of that answer. I don't believe I highlighted it over here. Yeah, so let's go back to the two secant lines. I consider this to be the easiest because the arcs are like right between, right? All of the arcs are between in these scenarios, but these arcs are kind of easier to see because they don't even touch at all. It's just this larger arc and this smaller one, right? And you would subtract those and take a half of the answer. Okay, moving on to our last intersection that happens outside of the circle is when you have two tangent lines. So tangent lines don't go inside of the circle at all, right? Tangent lines only touch the circle in one place. So watch what happens here, right? In order to get the measurement of angle A, you would have to take half of the measurement of arc BDC minus the measurement of arc BC. Right, so notice how point C is in both of these arcs. So we actually end up completing the circle, right? We take this larger BDC and then we subtract the smaller BC and then of course take a half of that. But notice in the image, right, you've done the entire circle, because the tangent lines don't go inside of the circle at all. So they're not cutting the circle. They're not cutting through. Whereas when you have a secant line, the secant line does cut through the circle. So this piece is not a part of the equation at all. And then when you have two secant lines, they both cut inside the circle. So you have two pieces that are not a part of this equation. Okay? All right, let's go ahead and get started. These are going to be the most problems because there's three different types of exterior intersections. So bear with me. It's a video anyway, so, if you need a break, pause it, go to the bathroom, whatever it is you have to do. Go back and practice some of the other problems maybe before you finish. It's up to you. All right, let's start number 12. Number 12, they're asking for the measurement of angle BCD. So that is that little angle measure there. First of all, let's identify that this is two secant lines. Two secants. Because they're both going inside of the circle. One of the secant lines happens to be a part of the diameter. But they're both secant lines. They both are cutting through the circle, and they're also outside of the circle as well, right? Okay, so in order to solve this problem, going by what we've learned earlier, this measurement of this angle, you would have to take a half of the larger arc. So that's going to be arc AE minus the smaller arc. So that's arc BD. Okay. So that gives us a half of 67 minus, and I am going to need to find that smaller arc. Okay. So looking at the circle, first of all, I know that this arc here is 180 since the diameter is cutting through. Okay. So this arc is 180 degrees, meaning that this arc, hold on, sorry, let me erase that. Meaning that this arc plus this arc should total to, watch me draw it out, 180 degrees, right? So in that case, all I have to do is 180 minus 67 minus 94. And that is going to give 46-degree arc. Seems a little large. Hold on. Am I subtracting? Sorry. This is 19. It's not 46. This is 19. I'm like, that seems a little large for that little slither. And I'm subtracting 94 from 180. This is only 19. Okay. So now I can fill in that the measurement of arc BD is 19. And then taking a half of 67 minus 19, you're going to get 24 degrees for this angle BCD. All right. Number 14. Again, with number 14, you have two secant lines. But now we're looking for the measurement of arc QU. So first of all, I'm going to just start by creating my equation by what I knew earlier. Just looking here, we have two secants. So I want to write this exact equation. I want the measurement of that angle of intersection between the two secants will equal a half of the larger arc minus the smaller arc. Okay. And you know what? Let's go ahead and write that in here too. Like, this is large arc minus small arc. And angle A is the angle of intersection, because it's very specific what these pieces are, right? This angle pertains to the angle of intersection between the two secant lines. And you always take the large arc minus the smaller arc, right? So that you don't get a negative number. And that would be the same across all problems. I mean, all scenarios. Well, all problems also. Okay, let's go back to 14. So we should be able to set up here that the measurement of angle, in this case, that would be angle TSR, this angle here, will be equal to the larger arc, which is the one we're looking for, QU, minus the smaller arc, and that's going to be TR. So now just filling that in, we're going to get measurement of angle TSR is 35. Measurement of arc QU is X. We don't know. Oh, I'm sorry. Hopefully you noticed this mistake, but we should be taking a half of that. Okay? So we're doing a half. A half of the measurement of arc QU, which is X, minus the measurement of arc TR, and they gave us that is 46. Distributing the 1/2 and then solving for X, you're going to get 116 for X. So please do the algebra on your own. Okay, number 16. In this scenario, we have one secant line and one tangent line. So here's your secant line going through the circle, and here's your tangent line that just touches the circle in one place. Okay. They want the measurement of angle ABC, so that's this angle here. And if you remember earlier, first of all, we're going to call that X. In order to get that angle, you're going to need to take a half of the larger arc between the two lines, which is going to be arc AD, minus the smaller arc that is between the two lines, arc AC. Okay. Oh, so now filling that in. First of all, I need the measurement of arc AD, right? So that's this arc here. And since I know that this arc is 88 and this arc is 62, then I could just complete the circle. So I'm just going to go off to the side and do 360 minus 88 minus 62. And we are going to get that arc would be 210. Okay. So now I'm going to say that X is the measurement of angle ABC, and it's equal to a half of measurement of arc AD. I just found that it's 210 degrees, minus the measurement of arc AC. That's in the green there, so that's 62. And a half of 210 minus 62. Pause this and get your answer. X is going to equal 74 degrees, and X was measurement of ABC. So we're done. Let's try number 18. Go ahead and pause the video now to see if you can solve this problem on your own. Remember that you want to start by setting up the equation based on the notes that you took above these problems. Okay, so hopefully you tried to solve this problem on your own. They're looking for the measurement of arc MK, so that's this arc here. And again, in order to find that arc, I'm going to go ahead and call it X for now. But in order to find that arc, I can say that the measurement of angle MLK is equal to a half of the measurement of arc NK, the larger arc, right? Minus the measurement of arc MK, which is the one we're trying to find. So I fill in this equation. The measurement of angle MLK is 56 degrees. That's equal to a half of arc NK is 160. That was given to us. That's the larger arc here in the picture. NK. Minus our arc that we're trying to find is measurement of arc MK, so that's X. Hopefully when you paused the video, you got that X is equal to 48. Done. And this was another example with one secant line and one tangent. Number 20. This is our last problem. In this problem, we have two tangent lines because they're both outside of the circle, only hitting the circle at one place. Okay? So this was the example where you're going to end up completing the entire circle since both lines are outside the circle. So in order to find the measurement of angle CDE, this angle here is what they're asking for. You have to take a half of the measurement of arc CFE. That's this arc here, C to F to E, minus measurement of arc CE. And that is this arc here. Okay? So I'm going to start off by finding that larger arc there. That's just going to be 360 minus 106. So that arc is 254 degrees. All right, now I can fill it in. We're going to call our unknown angle X. So the measurement of CDE is X, and that is a half of the large arc, 254, minus the small arc, 106. And so therefore, pausing, X equals 74 degrees. Okay. Just going to quickly browse and see if there's any problem that is slightly more difficult to do. Looks like we're good. I'm going to go ahead to the next page, arcs, angles, and algebra. And I'm just going to go down here to problem number 13. That's an odd problem. Let's do 12. Okay. So problem number 12 tells us that the measurement of arc DA is 23x minus 14 degrees. And then the measurement of arc DB is 9x minus 4 degrees. And the measurement of angle DCB is 5x plus 11. Last thing is to find the measurement of arc DA. Oh, let's highlight that in pink because that is the original arc that they gave us the expression 23x minus 14 for. So once we find x, we just need to plug it in right here, only there, because that's the only answer we need. All right, let's go. First of all, I want to identify that this is one tangent line, which is DC, line DC, and one secant line, which is line AC. Okay. So again, I'm going to first start by setting up that the measurement of angle DCB would be equal to a half of the large arc DA minus the small arc, dB. And I'm just going to be careful and make sure I use the exact letters that they used when they wrote the problem, right? Okay, so now the measurement of DCB, we're going to write 5x plus 11, because that's what they gave us for that. It's going to be a half of measurement of arc DA, 23x minus 14. Minus the measurement of arc DB. So that's 9x minus 4. Okay. So now we can kind of just solve for x here. According to PEMDAS, I need to first do what's inside of my parentheses or in the brackets that I have. So I'm going to subtract 23x minus 14 minus 9x minus 4. So we're doing 23x minus 9x. And that should give you 14x. And then we're doing negative 14. Sorry, I meant to use a highlighter. Negative 14 minus negative 4. So negative 14 minus negative 4, because there is like this little minus sign here. So it's actually negative 14 plus 4. So that's going to give us negative 10. And that's going in parentheses with the half and 5x plus 11. So now I'm going to distribute the 1/2 into the parentheses. So I'm going to have a half of 14x would be 7x. And a half of negative 10 would be negative 5. And then we have 5x plus 11 here. Okay. I'm going to subtract 5x from the 7x and get 2x. And I'm going to add 5 to 11 to get 16. So now I know that x is 8. Now that I found x, all I have to do is go back and plug it in to measurement of arc DA. So we're doing 23 parentheses 8 minus 14. So 23 times 8 minus 14. 23 times 8 equals and minus 14. So we get that the measurement of arc DA is 170 degrees. And we are done with that problem. Oh, let me use the original color that I had. All done.